All right, 7.6, double and half angle formulas. So for these, what you're going to see happening is kind of these major angles are going to be doubled as you work with them. And you'll see down below how it works, okay? So this is the double angle formulas. Sine of 2 times theta equals 2 sine of theta cosine of theta. Cosine has 3 different versions, okay? It has a cosine sine version, it has just a sine version, and it has just a cosine version. Okay, and these are all created by the fact that sine squared is 1 minus cosine squared is 1 minus sine squared. So they just fill numbers in and then get the other 2 versions. Yes? No, these will be on your sheet. Okay? For the CLEP, you need to memorize. This one?
Yeah, can't you flip it? It can be negative 1 plus 2 cosine squared.
Yep. Yep. It could be negative 1 plus 2 cosine squared of theta. Yep, flipped in opposite, because one would be negative, this would be positive. And then these are your half angle formulas, okay? So again, I don't have them memorized. For your test, I don't expect you to memorize them. But for your CLEP test, they could appear, okay? So here is how they work. So it says, use a formula above to solve the following. So for sine of 15, yesterday we solved that using the addition and subtraction ones, right? So today it wants you to solve them using the double and half angle formulas. Okay? So if it says sine of 15 is 30 divided by 2, correct? Okay? So sine of 15 equals sine of 30 divided by 2. You want it to be either a double or a half angle. So an example of a double would be that 2 times 60 is 120. Okay, that's a double. This one is half of the angles we know, right? 30 divided by 2. So you either want it doubled in size or halved. So this one's a half. So then I would go to my formula above, okay? This alpha is the 30 degrees. So when I see alpha over here, I plug in 30 degrees. So it's going to be positive or negative square root of 1 minus cosine of 30 divided by 2. Again, you need to know these 30, 60, 90, 45, 45, 90 triangles. So if it's cosine of 30, okay, if this is 30, this is 1, 2, and this side is the square root of 3. So that gets us positive and negative square root of 1 minus square root of 3 over 2 divided by 2. Which at this point then, they're going to have simplified versions of this. Okay? So first of all, if you see a big division like this, what should you change it to? The divide, which switches to multiplication. Okay? What should you do on top? Common denominators. Okay, so these are all concepts we're going to do now. So we get positive or negative square root of 1 minus square root of 3 over 2 divided by 2. Okay, I'm going to find common denominators of this, which gets me 2 over 2 minus square root of 3 over 2. So I'm going to put that together then. So I get positive or negative square root of 2 minus the square root of 3 over 2 times 1/2, because I switched that too. Now I did a lot of steps in one jump. So did any of those steps not make sense as I did it in one jump? They're all okay? Okay. All right. So now we have this. So we're multiplying these. 2 times 2 is 4. So from this, we have positive and negative square root of 2 minus the square root of 3 over 4. Now, if you have a big square root, that square root can be split. And it can just cover the top and the bottom. Okay? So it can be the square root of this over the square root of this, is what can happen. Well, what's the square root of 4? 2. So your final answer is positive or negative square root of 2 minus the square root of 3 over 2. That would be the most simplified version of this problem. And it's going to be very common for you to find a divide by 4 as you're working through these.
Every one of these problems is like, you gotta know how to simplify it each different way.
But remember, this is multiple choice. So my hope is that you'd get here and maybe you'd see the possible options and be like, oh yeah, the square root of 4 is 2. Okay? Yeah. Yes. Yep.
Is there any short answer on this?
I don't think so, because all of them are there's so much square root business going on. I don't think so. I think all of it is going to be multiple choice. I think the whole test. Like the only one that might not be is even the matrices I think all have to be. So.
What's that again?
It's like the little bracket.
Yeah. Where it was like 2 times 1, 3, 4, 7 minus 3 times 8, 9, 1, 6. I don't know. I can look it up for you though. All right. So let's try this again with this cosine 1. Okay? So for this cosine 1, what are you going to plug in for pi? 180. So from that, you get 7 times 180 divided by 8, which gets you cosine of 157.5. Horrible number. So number 1,
We have that.
do you think this is going to be a double?
Double.
No, because it's a 0.5. If it's a 0.5, it's going to be a half. And so I'm going to do 157.5 times 2, which gets me 315. So this is the cosine of 315 over 2.
I always like, in this half angle, you like multiply by 2, and then when it's double, you divide it by 2.
Yeah, it's pretty backwards, isn't it? Okay. Now, 315 degrees is a right triangle in this quadrant, correct? How far away is it from 360?
45.
45. So this is a negative 1, 1, and a square root of 2, correct? So the cosine 1 gives us a lot of options, correct? There's 3 of them. Oh, never mind. It's a half, right? So it gives us this one. Wow. So it's that one. So I would do positive and negative square root of 1 plus, what's the cosine of that? Square root of 2 over 2. Divided by, is it divided by 2? Yep. Okay. And then you would go through the same process that we worked through over here to simplify. Okay. Do you want to try simplifying it on your own and we can see how you do? Okay. as you guys finish up, set your pencils down so I know you're done. And then once everyone's pencils are down, or close to down, I'll start putting what the answer is. And then you forgot your big square root. Lots of 2's in square roots. All right, so you have positive and negative. Square root of 2 plus the square root of 2 over 2. So that's your answer.
How do you get the 2 of the bottom of it?
All right. So what you do is you would take this and you get positive and negative square root of 1 plus square root of 2 over 2 divided by 2, which gets you positive and negative. I'm going to find common denominators here, so I'm going to times this by 2 and the bottom by 2. So I get the square root of 2 plus square root of 2 over 2, and then times 1/2, which equals positive and negative square root of 2 plus the square root of 2 over 4. And remember that square root separates. So it's positive or negative square root of 2 plus the square root of 2 all over 2.
I got a question. For the double angle formulas,
Mm-hmm.
what would we, so we'd put sine, say it's like sine of 30 again.
Yep.
So we do sine 2 30
Mm-hmm.
equals 2 sine 30 plus half 30.
Yep.
But then this would just be a sine 30 because we already doubled it.
Yep.
No,
So it'd be 30 over 2, because 30 divided by 2 equals 15.
so then it was sine of 30. How would we get sine of like 60 or sine of
They don't happen often,
sine of 120?
but 120 you would just use the triangle on the left, right? So honestly, these are the only ones you really use to solve ones like these. Okay? All right. Hey! So we're going to go through, Connor just asked a really good question. He said, how would the double angles work? Because if you had sine of 60, well, you just do sine of 60, right? You wouldn't change that to 2 times 30. Or if you had sine of 120, wouldn't you just do sine of 120 because it'd be a 60-degree angle over in the second quadrant? So the double angle formulas, you don't really see those happening, okay? The half angle formulas are really what gets used in situations like this, okay? Those double angle formulas, I don't know of a situation where you wouldn't just use the angle you're given. Does that make sense? The double angle formulas are really used on proving things to be true, okay? But as Connor said, well, there's really, I can't think of a situation numbers-wise where you'd use a double angle formula, okay? Because even when you get really big numbers, you would just subtract 360 till you get in your range, and then it'd be in your range, and you can use the original, okay? So I can't think of one, Connor.
So that's when you like say it's like 375 or I'm just using 375 divided by 2 and then use it like
Yep. Yep. Yes.
So when you get like cosine, sine, cosine, and all that stuff with that number next to it, and it's on this section, you can use that half angle formula.
Yes. When it's real numbers, it's going to be a half angle formula. Okay? Or like this one, we could have used the addition formula.
Okay.
It's up to you which one you use.
So that 1/2 never will go to the top. It only goes to the front.
Yep. Because it's a divide by 2, so it changes to times 1/2. Okay? All right. So let's use these double angle formulas. So remember, you're always working on this left-hand side, okay? So you're always working on that left-hand side. So we have cotangent of 2 theta. What do you think you need to change that to? It'd be cosine of 2 theta over sine of 2 theta, right? That's what cotangent is? This is what we're trying to get to. Yes.
Why do we use theta anyway?
It's so theta is typically connected with radian mode. So it's kind of a hint that it's all in radian mode.
So like if you plug in x there,
That's degree mode. So it's just a connection thing. And I'm not really sure why that's the connection that's made.
but it's equal to like plugging in x.
Yes.
Okay.
Yep. It's the same thing as a variable. All right. So obviously with sine, we have to use 2 sine of theta cosine of theta. So the bottom is definitely 2 sine of theta cosine of theta. Okay? I went above and took my equation from above. Sine of 2 theta is 2 sine, that's the only option for that one. Okay? So cosine of 2 theta, well, let's look at the other side. We have cotangent squared. Cotangent squared on top is similar to what? It's cosine over sine. So if we need a cosine on top in the front, cosine squared on top in the front, you're going to use 1 or 3. My guess is you're going to use 1. No. Actually, it doesn't matter. Well, let's look. Well, this one has.
Number 1, because the 2 is on the bottom.
Yep. So let's use that one. So you have cosine squared of theta minus sine squared of theta. And then you have this business on the bottom. Okay? Oh, I see it.
Cosine squared of theta minus sine squared of theta equal cotangent squared theta minus 1. Isn't that true?
I'm not sure, but so I see now how they get the answer. Are you guys ready for this?
Sure.
Okay. What they do is they divide all parts by sine squared of theta. Okay? So, how I figured that out is I saw that they had a 1 here. Well, what do you need to do to this to get a 1 here? Divide by itself, right? And that gets me a 1.
Yeah.
But if I divide this by that, well, I have to divide all of these by that. Okay? So I saw there is a 1 here. Well, to make this a 1, I have to divide all of these by that. Okay? So what happens then is you get cosine squared of theta over sine squared of theta minus sine squared of theta over sine squared of theta all over 2 sine of theta cosine of theta divided by sine squared of theta. Okay? So again, I recognized that this turns into a 1. Okay? Since I recognized that, I asked myself, how do I make this a 1? Well, to make it a 1, I need to divide it by sine squared of theta. And now I have a 1 here, right? So what what I'm doing is I'm checking myself, comparing it to this one, and asking myself, how do I get there? Well, if I want a 1 here, I need to divide stuff by that. Okay? So constantly checking myself, saying, well, how do I get these pieces to line up? What puzzle piece would make that that? Okay, so now let's simplify this. And I think then you'll see, like, there's just one more step here. Okay? What's cosine squared over sine squared?
1.
Cotangent squared. Cosine squared over sine squared is cotangent squared of theta. Minus, what's sine squared over sine squared? 1. On the bottom, if I have 2 sines on the bottom and I have 1 on top, what can happen? One of them cancels, right? So now I have 2 cosine over sine. What's cosine over sine?
Oh, that's
That cancels with that. So I have 2 cosine over sine.
so you got 2
Cotangent. Yep. I wouldn't be on this, but this is like, this is the hardest they get. Am I going to give you the hardest that they get on your test?
Probably. You would.
No. Okay? Is the CLEP going to give you the hardest of the hard? No. Okay? This is trying to get in your head these ideas of change cotangent to sine and cosine versions. Okay? Check the other side. See how you're lining up. Okay? It's trying to get these processes through your head of things that you do to get to the end. Does that make sense? Okay? So, let's go ahead. Let's try this one. I have secant of 2 theta. What do I need to change that to? 1 over cosine of 2 theta. Okay? Now, my other version has secant squared of theta over 2 minus secant squared of theta. Okay? If it has secants, secants are with cosine, right?
Yep.
So should I use the cosine sine version, the 1 minus 2 sine version, or the 2 minus cosine version?
Probably no cosine.
Okay? So the answer here has secant in it. Secant is cosine. So are you going to choose options of sine if your answer only has cosine? No, right? If my answer only has cosine stuff in it, am I going to choose things that have sine in it? No. Right? Does that make sense? Yeah, no? Yes, right? This has cosines. I'm not choosing anyone that has sine. So the first one has sine, right? The second one has, what is the third one? No sine. So we're going to choose the one that has no sine. So that gets me 1 over, is it cosine? 2 cosine squared of theta minus 1. This is where I'm at. Okay? This one follows the same procedure we just did. If I look at this, okay, and I'm going to look at this piece. This piece just turns into what number? What does it just turn into? 2. Well, how do I get this to just be the number 2? Divide by cosine squared. If I want this piece to be the number 2, and I divide by cosine squared, wouldn't this piece just be the number 2? But if I do it to 1, what do I have to do it to? All of them. So let's divide all of them by cosine squared. Okay? And now let's simplify. If I have 1 over cosine squared, what does that change into? Secant squared of theta. Over. If I have 2 cosine squareds over a cosine squared, what happens? 2. Minus, if I have 1 over cosine squared, what does that change into? Secant squared of theta. Bam.
That was so easy.
Okay? So again, checking. I got here, I want to get here. Well, wait a second. I have a 2 here, but I have this attached to it. Well, I must have to get rid of this, so I'm going to divide. And when I divide 1, I have to divide everything. Okay? Just like if you multiply 1, you have to multiply everything. Do I have another example?
Yep.
Yeah. Okay?
Cosine squared.
All right. So this is 1 over cosine squared of theta over 2, correct? 1 over cosine squared of theta over 2. Okay? So Connor says we have to use our half angle formula, right?
Yeah.
Because it's theta over 2.
Oh.
The previous one was 2 theta, so we use the double. This is theta over 2, so we have to use the half. Now this squared, I'm going to change how I wrote this. What this squared means is I have 1 over the cosine of theta over 2, that quantity squared. Okay? That's what, these two mean the same thing. It's just a different way of writing it. Okay? I prefer this way. To me, this way makes more sense. But most mathematicians write it this way. Okay? So I changed it to this. So now the formula for cosine of theta over 2, I believe, was the square root of 1 plus cosine of theta divided by 2 in a square root. Okay?
Yeah.
So we have 1 over a big square root, right, of 1 plus cosine of theta over 2. And then remember, this is squared. Oh, yeah. We should probably talk about that part. Yep. Now, but my other question for you is, if you squared a positive, okay, what happens? You get positive. You square a negative, you get a positive. So you guys see why the positive negative disappears? Because if you square either, if you square a positive, it's positive. If you square a negative, it's positive. So does the positive negative have an effect anymore? No? And then if you square a square root, it's nothing, right? Okay, so let's change that then. So this is 1, and I'm going to use our division sign because I have some double fractions going on. So I'm going to do 1 divided by 1 plus cosine of theta over 2. Okay, so now there were some questions. I just wanted to get that far, hoping some of you can see how we get there. But what are the questions, Caitlin?
So the plus or minus, we don't include that in the grade.
The reason you don't is because if you square them, it goes away. Just like the square root and the square cancel, if I square a positive number and if I square a negative number, they'll both equal the positive version.
Does it always, do we always just get rid of it?
That'll always happen. You'll always notice this side won't have the positive and negative anymore because this is happening every time. Okay?
So every time, this is like, what I would have done is I would have crossed out the 2 and I would have crossed out the square root, and then I would have had positive and negative 1 plus cosine of theta over 2.
Yep.
So every time you have to like allow it in first.
Yep. Because it's outside. Yep. So if you had a 2 outside of the square root, you'd have to square the 2 as well. Yep. So if you have a number outside here, you have to square it. So if it's a positive negative, you have to square it. Yep. Other questions? Okay, so did everyone see what happened then? What happens to the division? Flip it. It's 1 times 2 over 1 plus cosine theta, and you're done, right? Okay? Surprise. Okay? So let's talk about, to me there were kind of 2 major concepts. Well, 3 I guess. Okay? So the first concept we kind of talked about was constantly checking where I'm going. Check where you're going. Where am I going? Where am I going? Where am I going? The second concept was that you can divide by things to move ahead, right? That's something we hadn't done before. We haven't divided by cosine squared to all 3 parts. We've times them, but we haven't divided. And then the third concept was if you square a plus or minus, it cancels out. Okay? Those, I think, were kind of the 3 major ones. Would you guys agree that we kind of saw? Okay. So, Becca, what are you going to ask? Yes. Because then you have answers in the back. Okay, so page 495. Let's see here. Okay, so what was my first part? 20 through 24? So do 19 through 23 odds. 48 through 52. Okay, so instead do 47 through 51 odds. Okay, and then 58 and 60. I must have really liked those for some reason. I do still like 58. I want you to do 58.
It must be really hard or something.
Oh, actually, no, you can do 57. So do 57 and 59. Okay? Becca, does that make you happy? Becca, can you repeat to me what I just said?
19 to 23 odds.
Yeah, I mean, if you don't do it,
47 to 51 odds.
doesn't
And
make
then
me happy.
57 to 59.
Okay.
so I don't do that.
All right.